Hello everyone, I'm Simone Carnemolla, and today I'll be discussing the work titled Back to Supervision Enhancing Word Boundary Detection through Frame Classification. Segmenting speech into individual words is challenging due to the variable length of the waveforms. In this study, we introduce a model-agnostic supervised framework to break down speech into word-level segments. Our approach combines frame classification with label augmentation and a frame selection strategy to achieve more accurate segmentation. For this study, we use two datasets. We utilize the Buckeye corpus for both training and testing, and the TIMIT dataset only for testing. Buckeye consists of 40 speakers from Central Ohio, each with 1 hour of recorded speech, which is annotated at both the phoneme and word levels. TIMIT contains recordings from 630 speakers, also annotated phonetically and lexically. From TIMIT, we used only the test set, comprising 1,680 samples. For our model-agnostic architecture, we experimented with both from-scratch and pre-trained encoders. We trained a CNN and a CRNN from scratch and also fine-tuned HuBERT large and Web2Vec 2.0 based models. The first component of our method is label augmentation, which consists of 3 steps. First, we applied bio-labeling at each time point in the waveform, where B marks the beginning of a word, I stands for inside a word, and O indicates outside a word. In the second step, we framed the labels into 25 millisecond intervals, translating time point labels to frame level labels. The third step, applied only to the training set, involves replacing the frame addition to begin frames with begin frames themselves, smoothing the transitions. The training process was kept straightforward. The input waveforms are passed through the audio encoder followed by a classification head. The model's predictions are then compared with the augmented labels using a standard cross-entropy loss for optimization. During inference, due to the label augmentation strategy, the model tends to oversegment, often predicting cluster of begin frames. To address this, we selected the average frame within each begin cluster as the predicted boundary, while discarding the neighboring frames to reduce oversegmentation. As shown in the results, HuBERT outperformed all other models. However, it's worth noting that we only found one recent supervised method for direct comparison. We also included results from some self-supervised and unsupervised methods not to create an unfair comparison, but to highlight the potential of a supervised approach in improving performance in this task. Thank you for the attention.